What if machines could understand not just your words, but your emotions? Imagine a system that can detect stress, anxiety, or even depression, just from text input. In today's world, where mental health challenges are increasing rapidly, the need for intelligent and accessible solutions has never been greater. In this video, we will explore how artificial intelligence, especially deep learning models like convolutional neural networks, are transforming mental health care. We will also walk through a complete system, from data processing to real experimental results. Mental health has become one of the most critical global challenges. Millions of people suffer from anxiety, depression, and emotional stress, yet a large percentage never receive proper treatment. This gap exists due to multiple factors: high cost, lack of trained professionals, and social stigma. Traditional systems are often slow, inaccessible, and not scalable. This creates a serious need for intelligent, automated, and accessible solutions. To address this growing mental health crisis, we introduce an AI-powered chatbot solution designed to provide intelligent and accessible support. At its core, this system leverages natural language processing to understand user input in a conversational manner, just like a human interaction. When a user shares their thoughts or emotions, the chatbot analyzes the text, identifies patterns, and responds in a meaningful and empathetic way. Unlike traditional systems, this chatbot is available 24/7, ensuring that users receive immediate support whenever they need it. Additionally, it maintains complete privacy, allowing individuals to express themselves freely without fear of judgment. This makes AI chatbots not just a technological innovation, but a practical and scalable solution for modern mental health care. Now let's take a deeper look at how this AI chatbot actually works behind the scenes. The process begins with natural language processing, where the system analyzes user input, breaking down sentences to understand intent, context, and emotional tone. Next, this processed data is passed into machine learning and deep learning models, where patterns are learned from large datasets. Here, the system identifies emotional signals such as stress, anxiety, or neutrality based on learned representations. Finally, the response generation module comes into play. Based on the detected emotion and context, the chatbot generates a relevant, empathetic, and meaningful response. This entire pipeline works seamlessly in real time, allowing the chatbot to simulate human-like conversations. As a result, the system doesn't just respond. It understands, making interactions more intelligent, personalized, and emotionally aware. The foundation of any AI system is data. In this system, structured datasets are used, containing conversational text along with emotional labels such as stress, anxiety, and neutral states. These datasets simulate real-world human conversations, allowing the model to learn emotional patterns effectively. High-quality data directly impacts the performance and accuracy of the system. Before feeding data into the model, pre-processing is performed. This includes tokenization, stop-word removal, and lemmatization. These steps remove noise and standardize the text, ensuring that only meaningful information is retained. Finally, the text is converted into numerical vectors, making it understandable for machine learning models. Now let's understand the traditional approach: support vector machines, commonly known as SVM. SVM is a supervised machine learning algorithm widely used for classification tasks. It works by identifying an optimal decision boundary, also called a hyperplane, that separates different classes in the data. In simple terms, it tries to draw the best possible line between categories like stress and neutral emotions. While SVM performs well on structured and simple datasets, it has limitations when dealing with complex textual data. Human emotions are often subtle, context-dependent, and layered, which makes them difficult to capture using fixed boundaries. As a result, SVM struggles to understand deeper emotional context in conversations. This limitation led to the need for more advanced models, such as deep learning approaches like CNN, which we will explore next. To overcome these limitations, we use convolutional neural networks. The input text is first converted into vectors, which represent words numerically. These vectors are then passed through convolution layers that act like filters, extracting important features and patterns from the text. At the core of this system lies a powerful deep learning model, the convolutional neural network. The process begins by converting text into numerical representations known as vectors. Each word is mapped into a numerical format that captures its meaning and relationship with other words. This transformation allows the model to process human language in a mathematical form, forming the foundation for deep learning. Once the text is converted into vectors, convolution layers come into play. These layers act like intelligent filters, scanning the text to identify important patterns, phrases, and contextual signals. Instead of analyzing individual words, the model learns combinations of words that indicate emotions, such as feeling overwhelmed or can't sleep. This enables the system to move beyond simple keyword matching and start understanding deeper emotional context. After feature extraction, pooling layers reduce the complexity of the data while preserving critical information. The refined features are then passed into fully connected layers, where the final classification takes place. At this stage, the model predicts the emotional state of the user, whether it is stress, anxiety, or neutral. This deep learning pipeline allows the system to achieve high accuracy and deliver intelligent, emotion-aware responses. Let's begin by understanding the overall system architecture of the AI-powered mental health chatbot. The system follows an end-to-end pipeline, starting from user input and ending with an intelligent response. When a user enters text, it is first processed through pre-processing techniques such as cleaning and normalization. This ensures that the input is structured and meaningful for further analysis. Next, the processed text is passed into the natural language processing module, where linguistic patterns are identified. This structured data is then forwarded to the deep learning model, specifically a convolutional neural network, which analyzes the emotional context of the input. Finally, based on the detected emotion, the chatbot generates a relevant and empathetic response. Now let's break down the architecture into its core components to understand how each module contributes to the system. The first module is input processing, where raw user text is received. This is followed by the pre-processing module, which performs tokenization, stop word removal, and lemmatization, transforming raw text into structured data. Next, the natural language processing module extracts meaningful linguistic features and prepares the data for deep learning. The core of the system is the CNN model, which performs sentiment classification by identifying hidden patterns and contextual relationships within the text. Once the emotion is detected, the response generation module uses predefined logic or AI-based methods to generate an appropriate reply. Finally, the system outputs a personalized and context-aware response, completing the interaction loop. Let's now understand how the system works in real time through its workflow. The process begins when a user enters a message, expressing thoughts, emotions, or concerns. This raw input is first sent to the pre-processing stage, where unnecessary words are removed and the text is cleaned and structured. Once processed, the refined input is passed into the deep learning model, specifically a convolutional neural network. The model analyzes the emotional context of the text and identifies patterns that indicate stress, anxiety, or other emotional states. Based on this analysis, the system prepares to generate a meaningful and context-aware response. Now let's break down the workflow into detailed steps. After pre-processing, the text is tokenized, meaning it is split into smaller units such as words or phrases. These tokens are then converted into numerical vectors, allowing the model to process the data mathematically. The CNN model then extracts deep features and identifies hidden emotional patterns within the text. Once the emotion is detected, the response generation module selects or constructs an appropriate reply. Finally, the chatbot delivers a personalized response to the user, completing a full intelligent interaction cycle. To evaluate the effectiveness of the proposed system, a comprehensive experimental setup is implemented using multiple performance metrics. The model is assessed based on key indicators such as accuracy, precision, recall, and loss, each providing a different perspective on performance. Accuracy measures the overall correctness of predictions, while precision evaluates how many predicted positives are actually correct. Recall, on the other hand, determines how well the model identifies all relevant emotional instances, making it especially important in mental health applications. Additionally, loss values indicate how well the model is learning during training, with lower loss reflecting better optimization. By analyzing these metrics together, we gain a complete understanding of the model's reliability, efficiency, and real-world applicability. Now let's look at the final performance comparison between the traditional SVM model and the proposed CNN-based approach. As we can see from the results, the CNN model consistently outperforms SVM across all major evaluation metrics. In terms of accuracy, CNN achieves significantly higher prediction correctness, indicating a better understanding of complex emotional patterns. When it comes to training efficiency, CNN demonstrates faster convergence, making it more scalable for large datasets and real-time applications. Additionally, the loss values for CNN are considerably lower, which reflects better optimization and more stable learning. These improvements clearly highlight the strength of deep learning models in handling nuanced and context-rich text data. Overall, this makes CNN a far more suitable and reliable choice for real-world mental health chatbot systems. The confusion matrix provides deeper insight into model predictions, highlighting both correct classifications and errors. This research introduces TED, an AI chatbot capable of understanding user emotions and generating meaningful responses with up to 98% accuracy. As we look toward the future, the potential of AI in mental health care continues to expand rapidly. The current system can be further enhanced by integrating advanced technologies such as voice recognition, facial expression analysis, and multimodal AI. Instead of relying only on text, future systems will be able to understand tone of voice, facial cues, and behavioral patterns, enabling a much deeper and more accurate understanding of human emotions. This will allow AI systems to respond more naturally, empathetically, and in real time, creating a more human-like interaction experience. Additionally, the integration of real-time data and adaptive learning models will make these systems smarter over time, continuously improving their responses based on user behavior. Ultimately, the goal is to build intelligent systems that not only detect emotions but truly understand them, making mental health care more personalized, proactive, and universally accessible. As we conclude, it is clear that artificial intelligence is not just advancing technology, it is transforming the future of mental health care. AI-powered chatbots are making mental health support more accessible, scalable, and intelligent than ever before. They provide instant assistance, maintain user privacy, and offer continuous support, bridging the critical gap between demand and availability of care. What makes these systems truly powerful is their ability to understand human emotions through data, identifying patterns of stress, anxiety, and depression with remarkable accuracy. However, it is important to understand that AI is not here to replace human care. Instead, it acts as a powerful support system, enhancing the capabilities of mental health professionals and providing early assistance to those in need. By combining human empathy with machine intelligence, we can create a more responsive, inclusive, and effective mental health care ecosystem. Looking ahead, as AI continues to evolve with advancements like multimodal learning, real-time interaction, and adaptive intelligence, these systems will become even more personalized and human-like in their responses. Ultimately, the goal is simple: to ensure that no one feels unheard, unsupported, or alone. AI is not just technology, it is becoming a companion, a guide, and a step forward toward better mental well-being for all. Thank you for watching. This journey into AI-powered mental health care shows how technology is evolving to understand not just data, but human emotions. From data processing to deep learning models like CNN, we explored how intelligent systems can deliver accurate, meaningful, and real-time support. As AI continues to grow, its impact on healthcare will only become stronger, making support more accessible and personalized for everyone. If you found this video valuable, don't forget to like, share, and subscribe for more insights into AI, innovation, and future technologies. Stay curious. and stay inspired.